November 2023, paper 4, variant 2. Question 1. A car accelerates uniformly in a straight line from rest at time 0. Okay. At t equals 3.2, the speed of the car is 13 meters per second. Find the acceleration. Well, acceleration equals
V minus U over T.
v minus u over t. V is the final speed, 3.2 minus 0 over the time, which is 13. What is the acceleration?
Wait, isn't the speed of the car 13?
Oh, 13, sorry. 13 minus 0 over 3.2, which is... Yeah, what's the acceleration? 4 point something, guys.
4.06
4.06
meters per second squared.
meters per second squared. What is meant by the term acceleration? What is meant by the term acceleration? Any ideas?
An increase or decrease in a change in speed.
Change in velocity, okay? But not just the change in velocity per unit time. The car travels at 13 meters per second from 3.2 to 12. Plot the speed time graph for the car from t equals 0 to 12. Car travels at 13 meters per second from 3.2 seconds to 12 seconds. What should I do?
Wait, so before the 3.2, it was not accelerating?
Before 3.2, what was happening to the car? It was accelerating. صح? It was accelerating. It took
Oh, okay.
It took 3.2 seconds to reach a speed of 13 meters per second.
Okay.
So 3.2 seconds on the graph should be, this is 3.2, which is this point, to reach the speed of 13 meters per second. The 13 meters per, yes, to reach this speed. صح? And then it continued on this speed for up to 12 seconds. يبقى initially it started at 0 and 0, and this would be a straight line because it was a constant acceleration. You should draw it using your ruler. And then up to 12, it was traveling with a constant speed. Easy. Determine the distance traveled between 0 and 3.2. What's the distance traveled between 0 and 3.2?
Distance is speed over time.
You cannot do that.
Oh, isn't the area under the graph?
Area under the graph. Area under the graph. What's the area under the graph? From 0 to 3.2, this is an area of a...
Trapezium?
لا, to 3.2, it's a triangle.
Oh, okay.
Okay.
So we're not doing the before.
He said from 0 to 3.2 only. Did he say up to 12? No. Half times base times height, which is half times 3.2 times the height, which is... I hate when this happens. Times the height, which is 12. Yeah, can someone calculate it for me?
19.2
19.2, and the distance is in
meters.
meters. Okay, simple. The car decelerates from 13 meters per second to 0 meters per second at a constant deceleration. The mass of the car is 1350 kilograms. The car travels 13 meters in 2 seconds as it decelerates show that the work done by the car is 1.1 times 10 to the power of 5 joules. What's the equation of the work done?
Force times distance.
Work is
Force times distance. Okay. Work done equals force times distance. Do I have the force?
No, but we can find it
We can find it. Okay. Force
using the
equals
math. G.
mg or ma?
Oh, okay. Yeah, MA.
Ma. G is acceleration. Yes, it is acceleration, but it's acceleration due to gravity. Is it free falling? Is the car free falling from a tower, for example? No, it's not free falling from a tower. It's decelerating. So there is an there is an acceleration or a deceleration, which is not 9.8. Mass is 1,350. What's the acceleration or the deceleration?
We got it. It's 4.06 from the previous questions.
4.06. Are you sure about that?
I mean, didn't we calculate in the previous question?
No. This is the different section of
Oh,
the graph. Now the car is decelerating, it's not accelerating anymore. It was traveling at a speed of 13 meters per second and it decelerated to zero in a time of 2 seconds. So you can find the acceleration again, v minus u over t,
so negative 13 over 2.
negative 13 over 2, or you can just ignore the negative, which will be 13 minus 0 over 2. Okay. Can I find the force now? Yes, I can find the force, which would be the force would be
doing it.
8,775.
8,775. Okay. This is the force. Can I find the work done now? Yes, work done equals force times distance, which is 8,775. What's the distance traveled? What is the distance? 13 meters. Yeah. It would be hmm. What's the final answer? Well, look,
1.14 times 10 to the power of 5.
times 10 to the power of 5 joules, which is correct. On another day, the car travels a longer distance while it decelerates from 13 to 0. The deceleration is constant. Suggest and explain what causes the stopping distance to increase. What could increase the stopping distance? What is one logical reason why the stopping distance increased? I'll tell you a very famous logical reason. If the floor was wet, okay, wet surface or wet floor or whatever. Why? When the floor is wet or when the surface is wet, less friction, okay, between between the tires and the surface. So when there's less friction, it will take more time or a longer distance for the car to stop. ماشي. Okay, I have an electrical tumble dryer. State the process by which the hot air removes water from the wet clothes. How does the hot air remove water from the wet clothes? Oh, basically, how do the wet clothes get dried? How do they dry up?
هي مش evaporation صح؟ عشان المياه ما
لا،
بتتبخرش
it is evaporation.
جوه الغسالة صح؟
It is evaporation, yes.
اوكي.
It is definitely evaporation. Okay. The air is cooled as it passes through the condenser. Describe and explain one other way in which the air leaving the condenser is different from the air entering the condenser. So the air is cooled as it passes through the condenser. Okay. Describe one other way in which the air leaving is different from the air entering. Hmm. Hmm. Any ideas? This is a new question. Okay, it's a new question. What could be different about the air? This is called a condenser. It's literally called a what? A condenser. What does a condenser mean? It means that it condenses the water vapor. It removes the water vapor. It removes literally the water vapor from the air. So if there was any water vapor in the air, it would have been removed, and therefore the air, while entering the condenser, it has a lot of water vapor. While leaving the condenser, it will become dry. Okay, so the air is drier. The air is drier. Why? Why? Because most of the moist, okay, most of the water vapor, mhm, most of water. What happened to the water vapor? It condensed. Okay, condensed in the condenser. Okay, it changed to water in the condenser. Okay. طيب. The drum and the tumble dryer rotates, lifting up the wet clothes, which then fall down. Name the force that causes the clothes to fall down. When they are lifted and then they fall down. What is the force that causes them to fall down? Hmm. What is the force that causes them to fall down? Well, it's a very simple force. Huh? Any
Uh,
ideas?
their weight,
Weight,
gravity.
yes. Gravitation force, weight, yes. When the drum rotates too fast, the clothes remain in contact with the wall of the drum. State the direction of the resultant force on the clothes during this circular motion. Oh, this is a key word. When there is a circular motion, state the direction of the resultant force. What is the direction of the resultant force? Circular motion. Hmm. Hmm.
Wait, the
لا
centripetal?
مفيش اصلا.
لا, there is centripetal. Where is the direction of the centripetal force? Yes. Huh?
Towards the center.
Towards the center. Oh, towards the center of the rotation. Or you can say that this is perpendicular. Okay. Perpendicular to the motion. Okay. It is definitely perpendicular to the direction of the motion. Suggest why using clotheslines to dry clothes in the open air is better for the environment. Why is it better for the environment than using this tumble dryer? Why would it be better for the environment than the tumble dryer? Hmm. Any suggestions?
Because the energy is clean and it's like renewable.
Clean energy, okay. It doesn't produce any greenhouse effects. It doesn't use any fossil fuels. It doesn't require any electricity. Okay. It uses the sun, which is renewable. Uses the sun, which is renewable. You can say it doesn't cause any greenhouse effects. ماشي. Okay, good. A balloon of mass 15 grams is glued to a straw. The straw is threaded onto a horizontal string. The balloon is filled with air and then the air is released. As the air leaves the balloon experiences a force. The balloon accelerates from rest until it reaches constant speed. It then travels 0.67 meters in 0.18 seconds at this constant speed. Explain in words what is meant by the term impulse. What do I mean by the term impulse? What's the equation we use to find impulse? But
It's
the
changed.
change in momentum or the other one, which is
Force times time.
force times time. Force times. Calculate the resultant impulse on the balloon while it is accelerating. How can I find the resultant impulse? You said force times time. Okay. Do I have the force? Oh, you said it's the change in momentum. Okay.
So we can use the mv minus mu equation.
You can use it, but do you have the V and the U?
No, we don't.
No, we don't. What should I do?
We can find the mass. I mean, we can find the force using the mass of the balloon. What is that?
Or you can find the V using the distance and the time. Okay. It is reasonable to actually use impulse equals mv minus mu in this equation, in which I would say, well, V is equal to, okay, velocity is equal to distance over time. The distance is 0.67 divided by the time, which is 0.18. Okay, can someone find the velocity? 0.67 divided by 0.18, which is
3.7.
30, what? 3.7?
Eh.
Okay, 3.7 meters per second. Can I use an impulse equals mv minus mu? mv minus mu. Do I have the mass? Yes, it's 15 grams. Can I use 15 grams?
We have to convert it to kilograms.
We have to convert it to kilograms, which will be 15 grams to kilograms. What should I do?
Divide by 1000.
Divided by 1,000, which will be 0.015 kilograms. Okay. mv minus mu. So it's 0.015 times the velocity, which is 3.7. Yeah. This will be
0.055.
5 what?
0.055.
5 ماشي. Newton seconds or kilogram dot meter per second. Explain how momentum is conserved as the balloon
I
accelerates.
have a question.
Hmm.
ان the 0.015 انا طلعت لي 0.0148
0.01.
راوند هنعملها راوند كده عادي 2 سيك بس
اوكي 0.014. هو ايه ال 148؟
148
انت
اللي هو
ماس ليه؟
ولا هو
لا 0.50 0.015 عادي.
ماشي.
Explain how momentum is conserved as the balloon accelerates.
Is that the law of conservation?
Yes, law of conservation of momentum. Okay, but how is it used in this question? Or how is it conserved in this question?
Like the momentum of the balloon before it is released is equal to the momentum after.
Okay, and you can say that the momentum of the air leaving the balloon to the left is equal to the momentum of the balloon itself moving to the right. Now, there is some air which is now moving in this direction, and the balloon will move in this direction. The momentum of the air moving to the left side is equal to the momentum of the balloon moving to the right side, which is the law of conservation of the momentum. Okay. المومنتم of the balloon moving to the left side is equal to the momentum of the balloon, momentum of the, sorry, no, I meant the air. Okay, of the air moving to the left side is equal to the momentum of the balloon moving to the right. Okay. Figure 3.2 shows the directions of two forces acting on a different balloon as it moves. Determine the magnitude and the direction of the resultant force on the balloon relative to the horizontal. Okay. How can I find the direction and how can I find the resultant force, first of all? How can I find the resultant force? Any ideas?
We can
Hmm.
we complete the triangle and figure out the resultant force. نعمل
يعني
diagram يعني.
you will complete the triangle كده؟
Yeah.
لا, it's wrong. Okay? You cannot complete the triangle this way. ليه? Okay. كده you will say, for example, that the resultant force is in this direction, or is it in the other direction? Where's the resultant force? Where?
Down.
It should be downwards. The resultant force يا شباب should be in this direction. This is the resultant force. طيب, how should I draw the diagram? Do I need to draw the diagram? لا, you do not need to draw the diagram. You do not have to draw the diagram. But it's a good practice to draw it so that you would know where is the direction of the force. Okay. Initially, you had a force which was 0.4 newtons in this direction. صح? And then you had another force which was 0.74 newtons in this direction. This is called the head to tail method. Okay, head to tail method. Again, you're not required to draw it. You are not required to draw this triangle, but it's a good practice to just draw it to know where's the direction, where's the final resultant force. Initially, it was moving this way, and then another force was acting on it downwards. So the resultant force will be in this direction. This is the resultant force. How can I calculate the resultant force? This would be easy. How to calculate the resultant force? Yeah. Can someone tell me?
It's 0.4 and
0.4.
we're going to square both of the numbers.
Okay. Pythagoras, صح? We're going to use Pythagoras. So square root 0.4 squared plus 0.74 squared, which would give me a magnitude of
0.84.
0.84 newtons. Where is the direction of the force. I need to find
Down.
the direction. لا, you can't say downwards. You need to find the angle. You need to find the angle of this force. He said relative to the horizontal. So he needs this angle. He needs this angle, theta. How can I find this angle? Any ideas?
Yes.
Hmm.
It's a right angle triangle. He's giving us الopposite والadjacent. فنستخدم كده tan.
Yes, tan, exactly. So tan theta is equal to 0.74 divided by 0.4. To find theta or to find the angle, it would be tan inverse 0.74 divided by 0.4.
61.6.
51.6.
61.6.
61. Okay. 61.6 degrees. That's it. شباب بص, whenever he says he needs the direction relative to the horizontal, whenever I say the direction relative to the horizontal, the theta or the angle would be tan inverse y over x. What do I mean tan inverse y over x? Tan inverse vertical over horizontal. If for some reason, he says I need the direction relative to the, if he says relative to the vertical, which is very rare, okay, if he says relative to the vertical, what should I do? I will say tan inverse x over y, which is the horizontal, over the vertical. Okay, this is quite rare. Most of the cases, usually he says find the direction relative to the horizontal, and that's why most of the cases we say tan inverse y over x, or tan inverse the vertical component over the horizontal component. Okay. Figure 4.1 shows a bottle part filled with water. The air inside the bottle is at the same pressure as outside the bottle. The bottle and the contents are at room temperature. The temperature of the bottle and its contents are increased. State in terms of particles how the air pressure inside the bottle changes as the temperature increases. How does the air inside the pressure inside the bottle increase? What happens?
So, if the pressure is increasing, then the volume would be constant.
Okay, so I will consider the volume to be constant.
Because
Why
he
did
didn't mention it.
he didn't mention it? Okay. Okay. What's happening to the how the pressure inside? He didn't say that the pressure increases, على فكرة. And you need to say that the pressure increases.
Oh, so like as the temperature would increase,
Okay. When the temperature increases, what
Yeah.
happens?
the kinetic energy would increase.
Yes. Kinetic energy of the molecules. Okay, kinetic energy.
So they would hit the wall like faster,
Yes.
and then that would lead to increase of pressure.
Okay. Air molecules hit the, you have to say hit the walls. You cannot say hit each other. Hit the walls faster and harder, increasing the force. Increasing the force, or you can say changing the, or increasing the change in momentum. Okay, causing a greater change in momentum. Okay, which will definitely increase the pressure. Now the lid is removed from the bottle. State and explain how the air pressure inside the bottle changes. When I remove the lid, what will happen to the air pressure?
It would decrease because the
Yes.
surface area increased.
Okay, so the pressure decreases. Why?
The surface area increased, like now they can
Okay,
hit the walls of the room.
pressure decreases. Not because the surface area decreases, but because the air molecules escape from the bottle. Okay. Air escapes from the bottle. Okay. The air now is higher. The pressure is now higher than the room pressure. Whenever I will open the bottle, the air will leave, the high energy particles will leave the bottle until the pressure, okay, until the pressure is equal to the surroundings, okay, or to the surrounding pressure. Okay. ماشي. The mass of the water in the bottle is 0.18 kilograms. Specific heat is 420, 4,200. Calculate the thermal energy needed to increase by 20 degrees. Yeah. What's the thermal energy? What's the equation we'll use?
E is equal
mass
to
times
MC.
specific heat capacity times change in theta temperature. So change in temperature.
ماشي.
حاجة
0.18 times 4,200 times 20. Yeah, someone calculate it for me. Can someone calculate it? What's the energy needed? Nothing?
15,120.
Okay, in standard form, 15,000, 1.5, I guess, times 10 to the power of 4
Or
joules. Another plastic bottle is filled to the top with water. The height of the bottle is 40 centimeters. The density of the water is 1 times 10 to the power of 3. Calculate the pressure difference between the top and the bottom of the water. How?
pressure is equal to rho GH.
Yes, pressure equals rho GH. Rho is
1 times 10 to the power 3.
okay, which is 1,000 times G 9.8 times the height
40.
40.
can I
احنا
use
المفروض نعملها convert
have to
لمتر.
you have to convert it to meters, so divided by 100, which is 0.4. This will give me a difference in the pressure of how much?
3,920
3,920 unit
Pascals.
Pascal. Okay, good. Figure 5.1 shows a road junction, car moving. Driver of the truck is at position X. The car moves around the corner. Label a point Y on the road where the truck driver first sees the car. Okay. The driver is at position X. Okay. On figure 5.1, label point Y on the road where the truck first sees the car X. Where could he first see the car X?
Wait, so he's moving to the direction of the car? Or the opposite?
We'll assume that the car is stationary. We'll assume that the truck is stationary. Okay. He is at position X. But the car is moving around the corner. Now the car is moving around the corner, right? So at which position, okay, for example, uh, which position, okay, will the car first appear to the truck?
Like without the mirror, it would be the closest to the truck.
Without the mirror, it would be very close to the truck, correct? Okay. Um, okay, so it's almost somewhere here. Okay. It's almost somewhere here. Without the mirror. That's why they added the mirror. Show how this mirror allows the driver of the truck to see the car when it is at position 5.2. Okay. Now the truck can see the car more clearly or at a larger distance. Why? Because the mirror will show a reflected ray of the car. Correct? Okay. For example, we can draw straight line.
will it be at the curve?
ما بس we can draw a straight line this way. Okay. وهنا نعمل normal line. Oh. So now the truck can see the car when it's at this position. It doesn't need to wait for the car until it reaches the end of the curve so that he can see him. لا, he can see him while he is still at this position. Okay. Again, how do you draw it? It's very simple. Okay, you just need to draw a straight line all the way to the mirror and then a small dashed line, a small normal line, and try to, as much as possible to make the angle of incidence equal to the angle of reflection. I know my angle of incidence isn't that much equal to the angle of reflection, but you need to draw it as accurately as possible. You don't need to be 100% accurate, but try as much as possible. Okay? Okay. Yeah. Moving on to the next question. Hello, I like this question. The truck driver wears spectacles to correct long-sightedness. Okay? He has long-sightedness. What do I mean by long-sightedness? It means that the rays will meet beyond the retina. So the rays, if we extend the rays, they will meet somewhere beyond the retina. So whenever he looks at any object, these objects will be very hazy. He will not be able to see them clearly. On figure 5.4, show how long-sightedness is corrected. Show how long-sightedness is corrected by adding a lens and continuing the path of the three rays. Continuing the path of the three rays. For example, initially, the three rays, as I said, will meet beyond the retina. They will meet behind the retina. How can I correct this long-sightedness?
Using divergent lengths.
Type. If you use diverging lens, the diverging lens will actually increase the focal length. In this case,
Conversion?
long-sightedness, what do you need to do? You need to decrease. Well, this already is a very long focal length. This is a very long focal length. You need to decrease this focal length. How can I decrease the focal length? By using a converging lens. Okay? By using a converging lens. I'll draw a simple converging lens. Okay? This is a converging lens. Converging. Why? Because the converging lens, what will it do? It will decrease the focal length. Okay, I will continue the path of the first one. Okay, and the path of the second one. This way. And this one is continuing straight. كده كده this one will not converge or diverge. This one will continue in a straight line. You are using your rulers to be more accurate. Okay, what will happen? Okay, what will happen to this line? It will converge. It will bend towards no, it will bend. Whenever it bends, what will happen? Oh, well, it bends a little, and then when it reaches the lens, it will bend a little. It will bend a little. Reaching the lens, Okay, I wanted to draw it to bend a little. When it reaches the lens, what happens? It will bend all the way until it meets at the retina. This will bend a little. Okay, when it reaches the lens, what happens? It bends again until they meet at the retina. Okay, that's it. Again, what did I do? What did I do? You must use a converging lens. Okay, they will bend, they will refract. Okay, they will refract, and then they will refract again inside the lens. They will refract again inside the lens until they meet, okay, at the retina. طبعا in this part you can be a little bit more accurate, and I can draw it a little bit more accurately, okay, in which it will bend a little, and then it will bend even more until it reaches the lens. It will bend a little, and then it will bend even more until it reaches the retina. This shouldn't be a straight line, okay? This will bend, okay? This will definitely bend, okay? It refracts. Okay.
يعني
Yep.
for short-sighted people you need to use diversion,
Yes.
with long-sighted conversion.
Yes. This is correct. Okay, now I have a flashlight. The electromotive force EMF of the battery is 4.5 volts. The circuit contains a 60 ohm fixed resistor. The current in the light emitting diode is 0.2 amperes. Calculate the potential difference across the LED. Hmm. How can I calculate the potential difference across the LED? Hmm. Any ideas? Hmm. يلا شباب. Any ideas? Okay.
Is it
Hmm.
energy over charge?
So do you have energy and do you have charge? No. We have the voltage of the battery, which is 4.5 volts. These 4.5 volts will be divided. Okay, some of them will be for the LED, and the other or the remaining voltage will be for the fixed resistor. What is the voltage? What is the potential difference of the fixed resistor? Can I find the potential difference? Can I find the voltage of the fixed resistor? V equals V equals
Uh, I times R.
IR. What's I? 0.02.
0.2.
What's R? 60. Can I find the voltage of the fixed resistor V equals IR? يلا. It would be
1.2.
1.2 volts. This was the voltage of the fixed resistor. What is the voltage of the LED now? Hmm. Can I find the voltage of the 4.5 minus 1.2, which will be 3.3 volts? Okay. Explain why the LED does not light up if the battery is reversed. Hmm. Why
The
doesn't?
resistor stops.
No, not because of the resistor. Not because of the resistor. Hmm. It's actually because of the LED itself. Why? LED literally stands for what? Light emitting diode. So the LED is a diode. LED is a diode. And what does a diode do? Okay, which prevents, okay, What does that do? It prevents the current from flowing. Okay, the current from flowing hmm, in the opposite direction. That's it. Okay, it does prevent the current from flowing in the opposite direction. The chemical energy stored in the battery is 1050 joules. Showed that the flashlight operates for approximately 3 hours. Show that the flashlight operates for approximately 3 hours. What should I do? Hmm. Yep. Any ideas?
Time is energy over power.
وإيش their power أصلا؟
ما you don't have the power. بالظبط.
Oh,
أو you can find the power. You can actually find the power.
energy times
You can find the power. What is the power in the electrical circuit? What's the power in the electrical circuit? P equals VI. P equals VI. V is 4.5 and the I is 0.02. 4.5 times 0.02. So the power of this circuit is
0.09.
0.09. What's time equals energy over power, which is 1050 over the power, which is 0.09. So it'll give me a huge number, which is what's the answer? What's the time?
1.16 times 10 to the power 4.
1.16 times 10 to the power of 4 seconds. How can I convert this to hours? How can I convert seconds to hours? Divide by?
Divide by 60, divide by 60.
Okay,
Divide by 3,600.
divide by 3,600, which would give me a total time of this will give me a total time of
3.24 hours.
3.2 hours. Okay. Calculate the total charge that flows through the LED in 3,600 seconds. Total charge that passes through the LED in... How can I find this?
Energy over voltage. See?
Or there's a much easier equation. Can't you use I equals Q over T? So basically Q equals IT. Current is 0.02 times the time 3,600, which is 72.
22.
What's the unit of the charge? What's the unit of the charge? You have to know it.
Coulombs.
Coulombs. C. Yes. Figure 7.1 shows some uses of electromagnetic radiation in different regions of the electromagnetic spectrum. Bluetooth uses the radio waves. Thermal imaging uses
infrared
الفوتوغرافي
visible light
طبعا visible light and the sterilizing medical equipment.
gamma rays.
ماشي. State the speed of electromagnetic waves. يلا. 3 times 10 to the power of 8 meters per second. A Bluetooth headset. Okay. الفريكونسيز from the range of 2.4 to 2.48 gigahertz. Calculate the wavelength when the frequency is in the middle of the frequency range. So basically it's 2.44. 2.44 gigahertz. How can I find the wavelength? How can I find the wavelength?
wavelength. ثانية مفيش speed. احنا جايبين speed.
Speed is constant.
Speed over frequency.
So wavelength equals speed over frequency.
But don't we have to like convert gigahertz? Can we leave it like that?
Yes, you have to convert gigahertz. What's gigahertz?
1 million hertz.
1 million is megahertz. If you had megahertz, that would have been 1 million.
Times 10 to the power of 9.
Times 10 to the power of 9. Times 10 to the power of 9. Okay. So 2.44 times 10 to the power of 9. This will give me a wavelength of... Yeah, can someone calculate it?
0.12.
0.12 meters. Suggest why a Bluetooth headset only works well over short distances. Why does it work well over short distances?
Because the wavelength of radio waves are weak.
The wavelength of the radio waves are weak. Yeah, it gets weaker, correct. Yeah, we can say so. Okay, it loses energy and gets weaker. It loses energy and gets weaker. Okay, حلو. Isotope of uranium is represented by, state what the numbers, 92 is what? Quite easy. What's 92?
92 is the proton number.
Proton number.
235 is the neutron number.
لا, not the neutron. It is not the neutron number. It is the nucleon number. Okay. Or you can say a mass. لا. Atomic number is the proton number. Okay.
Oh, okay.
Or you can say it's the mass number. Okay. Mass number is the same as the nucleon number. Uranium-235 is a fuel. State the process by which the energy released. What's the process by which the energy is released? Any ideas? Nothing? Nuclear fission, for example?
Oh.
Nuclear fission, the splitting of these atoms. Nuclear reactors, nuclear fission. Describe the mass and energy changes that take place during the process in a nuclear reactor. Uranium plus a neutron gives off a xenon and SR, I don't know what is SR, plus 2 neutrons. Describe the mass and energy changes that take place during this process. Yeah, any description could be right. What happens, for example, to the nucleus of the... Again, what do we want to do? We want to describe what is nuclear fission. Okay, what happens in the nuclear fission? The large atom is split into 2 smaller atoms. Okay. The uranium was split into 2 smaller atoms, the xenon and the SR. I forgot what the SR was. Okay, and in this process, In this process, thermal energy was released. Okay. Thermal energy was released in the process. Okay, good. Describe how thermal energy from the nuclear reactions is used to generate electricity in the power station. This is an old question. How do we use this thermal energy to generate electricity? Hmm. How do you use this thermal energy released? Can I instantly produce electricity? Or does it have to go through a long process? He wants you to describe this long process, which is hmm,
It has something to do with a turbine.
definitely it has something to do with a turbine. Okay. الانرجي الهيت energy boils water to steam. Okay, so the water boils into steam. This water, when it boils to steam, what happens? Steam
Is that high pressure,
is at high pressure, which rotates what?
which will rotate the turbine, and
Okay,
then connect the turbine to a generator. Yeah,
which
and then we would make energy.
okay, which rotates a turbine, which turbine rotates a generator, which in turn rotates a generator, which produces hmm, electrical energy. Okay, one advantage and disadvantage of using nuclear fuels instead of fossil fuels. Advantage and disadvantage of nuclear fuels instead of fossil fuels. What is one advantage when comparing nuclear to fossil fuels?
Like less greenhouse gases.
Yes, no greenhouse effects, no air pollution. Hmm. What is one disadvantage?
It's very expensive. And, like it's very dangerous too if there's a leak.
Okay, it is very expensive, very dangerous if it leaks. Yes. We have some planets. The Earth has a mass of 5.97. Okay, distance is 149 million kilometers. Orbital period is 365. Gravitational field strength is 9.8. Jupiter, and then X. State the name of planet X. We need to.
Venus.
Hmm?
It's Venus.
It is Venus. Yes, it is Venus. Okay. It could have been Mercury or Venus. Okay, it could have been Mercury or Venus, but Venus is even closer to the sun. Mercury. Okay, Mercury is even closer to the sun. Venus is an average distance. Okay, Earth is 150 million kilometers. Venus is a bit closer, and Mercury is so close. Okay, Mercury has an orbital period of a much shorter time. Describe the relationship shown in table 9.1 between the mass and the gravitational field strength, which is quite obvious. Between the mass,
As mass increases, the gravitational field strength increases.
definitely, yes. As mass increases, gravitational field strength increases. Explain why the distance from the sun is an average value. Explain why the distance from the sun is an average value. Why isn't it an exact value?
It's not circular.
It's not circular. صح. It is not circular. It's an elliptical orbit. Okay. Planets have an elliptical show the average orbital speed of the Earth is approximately 30 kilometers per second. Can I find the average orbital speed of the Earth? Do you remember the equation? 2 pi r. So speed equals 2 pi r over t. T is
2
the
pi
p.
r ده circumference.
2 pi r is the circumference. 2 pi r. What is the radius between the Earth and the Sun?
The average distance.
Average distance, which is 149.6 times 10 to the power of 6 kilometers. Times 149.6 times 10 to the power of 6 kilometers. And I will leave it as kilometers because you said 30 kilometers per second. Divided by the period. Now we know the period, which is 36.2. We know that it's 36. Okay. You can write it as 36. I mean, so 365.2. But this is in days. He wants it in. He wants it in
24
seconds.
right,
Times
24 times 60 times 60.
times 60 times 60. Yes. Can someone calculate this using the calculator? Yeah. Can someone calculate it? This would give a total speed or approximate speed of
29.7 of 30.
29.7 kilometers per second, which is definitely equal to 30 kilometers per second. Okay, good. Last question. Complete the sentences about the life cycle of stars. Protostars are formed from what?
Clouds of dust and gas.
Clouds of dust and gas. Yes. Clouds of dust and gas, which is called a nebula. A protostar becomes a stable star when? When does a
The
protostar?
When the inward force due to gravity is balanced by the outward force due to pressure.
Excellent. Okay. When the inner force due to gravity is balanced by the outer force due to pressure. Okay. And temperature. The initial fuel used to power the nuclear reactions in stars is
Hydrogen.
hydrogen. Yes. Stars that are approximately the same size as the sun become red giants, which then form a what with a white dwarf at its center. The star after
Planetary.
planetary nebula. Correct. Which form a planetary nebula. Okay. حلو. Excellent.